guys, so today we are going to learn MapReduce by MongoDB. My name is Asim Jain and I am going to use the MongoDB documentation to give you a hands-on view of how MapReduce works. So right now you can see on my screen the official document of MongoDB says how this MapReduce works. So it's very simple. You can just go and grab basically the data to set it up. So we learn as we set it up so that it's easier for you. So what do I have now is a terminal which has MongoDB, and I'm going to insert some data right now. So I have the data in the orders, and what the data is we have customer with the name like the customer ID, their order dates and order price, and whatever are the the items they have ordered. And our aim is to get the price per customer, like how much one customer is purchasing. Just example, the person or the customer who spent the most money out of all will get a special recognition, right? So to do that, your database might have millions of records. So how would you do that? So this exercise will give us a tool so that you can just go directly in database and come up with the number which customer spent most of, like among all of these spent the money, highest money. So first phase was the data insertion which we did. Now we are going to do the map function. So what this map function is doing is, in the document we are mapping the customer ID with the price. So what does this mean is, this the customer ID, and then whatever is the price he or she spent in dollars, that is what it is going to be. So let's do this. So we have got the map function ready. Now we are going to do the reduce function. So what reduce phase does is, whatever the function you emit by map, which is the key and the value, it takes them and then you can do the operation to the reduce. Reduction is nothing else but summarize. So I have all these orders. Now in all these orders, I want to pick like do the sum of the order of particular customer and then give the results, right? This is what I am intending to do. So I'll grab the key in the reduce function. I'll grab the price as value prices, and then I'll do the sum. Now this is where people get confused. So I have a diagram of this. What we have is the key, which is customer ID, and the value. So if you will look at the result, like the data set, you see that ant has multiple records, right? And so that what will happen, that for each record there is a price associated with it, or each document has a price associated with it. So if we add this and this, all of these, whenever this reduce function comes up, all of these values piles up in an array. So the price of the first order and the second order of this person, third order. And essentially what we are doing is, we will, in the reduce phase, we will sum up all of these and then come up with one number, which is the summary basically, or which is the output of the reduce function. As simple as that. Let's run this and we'll understand it easily. So we have the reduce function. Now map reduce take three like multiple arguments, but map reduce would take the map function which we have defined, then it would take the reduce function which we have defined here. So map will map the customer with the price. Reduce will reduce all the prices in the array and come up with one number for a particular customer, and then it would return. And then we will do the output as map reduce example. So let's try to run this and see what happens. So now I am going to run this. So it is going to run the map reduce, and then it will put it in the output basically. So the output uh, might the output might be this. So let's see, db dot, let's say, show collections. So we see this. So whatever is the result, it came and the output happened in this collection. So we can always do db dot this dot find. So we'll see all the records. So Ant spent $95 and Don spent 155. We can always sort this. So we can say sort, and when we do a sort, we can have the key on which we want to sort, which is value here, and then we would do like this. So the first person with the highest spent is Don, and we were able to do a lot of things so quickly using the map reduce, right? So reduce did this, we were able to sort, and we were able to do things. Now, map reduce basically, when the conclusion or the reduction which came, it came to the collection which we have defined, and then it has the ID and the value. Now, what was the value? So typically the value was the sum of this. You could always change that value, like based on how you want to reduce. That logic would go here. In our case, we just did the sum because all the prices from each order piled up in the array. So we did the summation, and that's what we returned. But you can do several other things that depends on the logic. So this was MapReduce in MongoDB. It's also used in Hadoop with little bit differentiation, because their more intention is to do parallel processing on multiple nodes. So they would do the map phase, and then they would do the shuffle, and then they'll do the reduction on different nodes. And once that reduction happens, they would put it the result in some collection or some particular node from where this result can be read or can be consumed. So overnight, every day they would run these analysis. For example, the person who is spending more. So then the person who spent more in last day, they might send them some offers on the email or something. So it is being used a lot, the map reduce thing, especially in big data in Hadoop and in BI as well, right? So there is also another alternative in MongoDB to do or to get the same results by using the aggregate. So that is what I am going to tell you now, the aggregation solution. How this works is you have, instead of using the map reduce, you are going to group by customer ID. What does that mean? It means that whatever the users you have, so you find distinct on user like customer ID. So this will be like the customer ID with this common ID will be collected together, and they'll be grouped together like whatever are the different names, right?
Instead of using the
So
map reduce.
so now what will happen here is, let's come in the aggregation, and we will do the aggregation, and then we will have the value for this customer ID, which will, so we are doing the sum of all the prices. And once all this happens, we are going to make the output in this function. So let's do that. So we did a group by customer ID, and the value for that group will be the sum of all the prices for that customer. All this is the phase one in the aggregation. Phase two is the output. Whatever the the result of the aggregation in the phase one, it goes to the alternative. So let's say show collections. Now we see this. So if we say db dot this aggregation, and we see the same result. So result is same, processes are different. They are two sweet alternatives. It depends on which one you would like to go and when. I'm a big fan of MapReduce because you get a lot of flexibility when you're reducing. So you can do the same map function, but you can have multiple reduce function. For this instance, when we came up with the price, we could have also come up with the items, the maximum number of items purchased by a customer. So we can do a map accordingly. Instead of mapping by customer ID and price, we can do the mapping by the customer ID and items. like the count of the items, and then do the result or the output as well. So if you have sharding, or if you have a very big data which is scattered, MapReduce works best. Aggregation pipeline would of course work, but in the smaller piece. If you have super large big data, MapReduce is where you use. I hope you learned it's something good in this video, and please like and subscribe to my YouTube channel. Press the like button there, and share my channel. It's a technical channel where I share about programming, about big data, NoSQL databases like MongoDB, AWS, clouds, multi clouds, and lot many things. Thanks, guys. Enjoy, and bye bye.